And hello everybody, Mr. Cowan here to help you with Unit 3, Lesson 6, entitled Reasoning with Tape Diagrams. Our goal today, ladies and gents, let's go ahead and use tape diagrams to write the equations for different scenarios. Now, I'm going to ask you to pause, make sure you got the warm-up taken care of. Pause, come on back when you're ready, please. A couple things I notice here. I notice we got different variables. I notice in the bottom we have only one variable in each box, even if they're different variables. However, in the top, we got a plus b. I also noticed that they're different lengths. So here I see C and Z are different lengths. It makes me wonder, would we ever be able to figure out what they are, either what C and Z are in comparison to each other or just isolated and alone? Would we be able to solve A and B and X and Y? So those are a couple of the things that I happen to notice. Let's go ahead now and head to the next page, shall we? That was page 230. I should have said that. So let's go to page 231. All right, if you wish, you can pause, read this on your own, or else you can read it together with me. Here are two stories. Each story is a tape diagram that represents it. For each story, we got a couple things going on. All right. We have number one, explain how the diagram represents that story. Number two, describe the unknown amount that's given in the story. And number three, write a question about the story the diagram could help answer. All right, again, if you wish to pause, go ahead, but otherwise let's do number one together. Pashidu ordered 50 limestone blocks for the foundation of a pillar. Among his 5 workers, the first worker was given 18 blocks, while the remaining blocks were divided equally among the other workers. Now I'm going to pause. I'm just going to say this problem back without using numbers. We got a person that ordered some blocks, lots of blocks, got a bunch of workers. One person got a certain number of blocks, and then the rest of the blocks were divided up so that the same number was divided among the rest of the workers. Okay, so let's go ahead now to texting right now. Explanation. What do I see in the pictures? Well, 50 blocks total. One guy, one worker, had 18 blocks. And then there's 4 workers with X blocks each. Now I want you to pause and just think about how this relates to where we were a while back. A while back we had a hanger diagram, and we'd have 18 on one side and then 4 X's on the other. Nope, excuse me, on the same side, and then we'd have 50. So look how a tape diagram is similar. Look how it's different. It's similar in that they got 2 numbers written, 50 and 18. They got 4 unknown amounts, 4 unknown X's. But very different in terms of the hanger diagram shows a balance. One side is equal to the other. Tape diagram doesn't show a balance, but if you added up 18 and 4 X's, it's going to equal that total of 50. So there's some similarities here. There's some differences. I just wanted to show that. Let's go ahead and slide down. What is the unknown? The unknown would be number of, well, let's write in complete sentences, Mr. Cowan. Our unknown describes the number of blocks the 4 workers have, each of the 4 workers have. What question could we turn this into? Well, the question is, how many blocks did each of the remaining 4 workers have? So you see how we can take a tape diagram and a situation, and we can A, understand what the visual representation means, where it came from. B, understand what is our unknown amount. Now, by the way, you could have written let X represent the number of blocks each of the 4 workers have. And then lastly, we can go ahead and write a question for this problem. Pause if you need, rewind, watch the video again. Otherwise, let's go on to number 2. And again, I would invite you to pause it now, do number 2 on your own. Come on back when you're ready. All right, so what's this problem about? Stack of gold foil equally, so he distributed equally. That to me says it's split up. 5 workers, notice I circle numbers and what they mean. Underlining key math words, distributed equally. Also needed some gold foil to decorate. I actually don't care. This is where you can eliminate extraneous information. Asked for 2 sheets back is a keyword from each worker. After they gave them those sheets, they had a total, there's a key math word, 40 sheets left over. So look, 40 is that total. Notice I almost would say W, but then look where that W minus 2 ends up. Because each of those people are asked to give back 2. All right, let's go to the explanation now. We're asked to explain how the situation is represented in the diagram. And I'll do green for this. Five groups of W. Should I say it now? Should I say it later? 5 groups of W minus 2 sheets, all equaling a total of 60. 40, excuse me. All right, what's the unknown? Let W represent the number of gold foil sheets, the number of sheets originally given to each worker, which then, folks, I can quickly turn into a question. How many sheets of gold foil were originally given to each of the 5 workers? Pause if you need to, rewind. You could even look at the entire page together. How are these problems similar? How are they different? Well, they're similar in that they have a total number for the entire tape diagram. They're similar in that they have variables listed, but they are quite a bit different. This has 18 and then additional x's. This has 5 sets of W minus 2's. I have a feeling you guys are already trying to write equations out, but notice it didn't ask us to write equations. Explain how the diagram is representing the story, describe an unknown amount, and write a question for it. All right, we're going to skip activity 2, folks. Go on to page 233. Pause if you need, come back when you're ready. Look at the directions here. Match each equation with the tape diagram it represents. You may use some equations more than once. That is okay. Just be prepared to explain how each equation is represented with the diagram. So I think what I'll do is I'll start off with a few of these problems, maybe I'll do A and D, and then I'll let you complete the rest, and then you can come back and check. So let's take a look at A. So if I were writing an equation for this, I'm going to squeeze it in right above it. I see 5, I see an additional 2x's, and if I put all of that together, it would equal 19. So I'm going to take a look. Let me make this a little thicker, y'all. 5, do I have a 5 plus 2x? I do, right here. Well, actually, that was 19 is equal to 5 plus 2x. And I really shouldn't cross that off because we might use it more than once, right? Now, going back here, I'm wondering, is there any other equation that could have described the same situation? Well, sure. Why not write the 2x in front of the 5, and if you put those together, so there's another one. We've already used 2 of these. Anything else? How about 2 plus 5x? Nope, 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 not Mr. Callan. Nope. That's 5x's. That's not 2x's, so it can't be that. Anything else? I think that takes care of it. Again, you may use these equations more than once, so be careful with that. Let's go on down to let's go down to part D, shall we? Now for part D, what I'm seeing here is I'm seeing an x plus 5. Excuse me, actually I'm seeing 2 of those groups. It's not going to let me write off to the side. 2 of those groups of x plus 5. Let's rewrite that, shall we? 2 of the groups of x together with the 5. And if I put those together, it would equal 19 in total. Do we have any equation up above that said, oh, look, the exact same thing right here. 2 sets of x together with 5 will equal a total of 19. Is there anything else here? I almost went to this one, but wait a second. That's 5 sets of x plus 2, not 2 sets of x plus 5. So that's not going to work. Oh, how about this one? X plus 5 grouped together, and we have 2 of those groups. In the end will give us 19. Anything else? Anything else? I think that's it. All right, at this time, go ahead and pause your video. I want you to complete parts B, C, and E. And remember, folks, you may reuse the green, the blue, the purple equation or equations if needed. So go ahead, press pause, come on back when you're ready. Can I just point out, ladies and gents, what might seem obvious? These 2 equations. Well, that copied everything, and I don't want it to copy everything, so let's try that again. Or not, I'll delete. All right, let's try that again, shall we? So again, I know it might seem interesting, but we're going to use the same equations because we have together here 2 x's with an additional 5. That equals a total of 19. Go on down to part C, please. 2 put together with 1, 2, 3, 4, 5 x's equals 19. Anything else that could describe that one? I don't think so. All right, then on down to the bottom, where you guessed it, we have 5 groups of x put together with 2. If you looked at all 5 of those groups, and let's see here. I think that might be it. Now, if you need a challenge, go on down to the bottom. Pause. Come on back when you're ready. All right, ladies and gents, go ahead and check them. 2x plus 10 equals 19. That would be when this disappears. That would be under choice D, just so you know. 19 divided by 2, well, that also appears to be choice D. If you took 19, subtracted 2, and then that equals the leftover parts, that would go with choice C. And last but not least, if you took 19 and cut it into fifths, then each of those fifths would equal x plus 2. That would be choice E. Now you can take your own thoughts and write your own equations for any of these folks. So for instance, many of us, let me use a different color for this. Let's go to red. Many of us like to distribute. So why, instead of writing two sets of x plus 5, why not write 2x plus 10 equals 19? Yes, I know they already had that. Maybe you say 2x plus 5 plus 5. I don't know why anybody would do that, but it is an equivalent equation to that. For instance, up above, you could say x is equal to 19, take away 2, all of that split into then 5 parts. So you could have all sorts of different equations for each of these. In summary, what did we learn today? Go ahead and pause, read, mark up that text, come back when you're ready. So what is important to me is that we have tape diagrams that can kind of do something similar to hanger diagrams, but they have their differences as well. And like everything in life, there are advantages and disadvantages. We can use tape diagrams and equations to represent a similar situation. Because of the properties of addition, multiplication, as long as you're fair, more than one equation can represent a tape diagram. And what do we do? Sorry for that interruption. So when two or more equations can be used to represent the same diagram, the same real-world situation, we say that those equations are equivalent equations. Now take a look at the two examples down here. Stall at an Egyptian market at $48 in a basket. One shopper traded 44 of them. The remainder were divided evenly among 4 more shoppers. Well, we can write that in several different ways. 44 plus 4x, but what do we know about the property of addition? It is commutative. You can change around the order and it'll be the same thing. 4x plus 44. You could say 48 is equal to 4x plus 44. All of those are equivalent equations. On the right side, we get something that's a little different. Stall in a market has 48 olives. That sounds familiar. Olives came from 2 farms. The olives from the first farm were traded in equal amounts to 4 shoppers. When the olives arrived from the second farm, each of the 4 shoppers traded for an additional 11 olives. Okay, so that's 4 sets of X and 11. How do we write 4 sets? Well, that's when we use sets or grouping symbol notation, right? And of course, you can write 4 in the front, most of us do, but you may also write times 4 sets in the back as well. Interestingly enough, when you think about this, if you were to distribute, what equation do you get? You get 4x plus 44 equals 48. Very different situations, also leading to the same equation. And of course, we know how to solve that. You would subtract 44 from both sides. Remember, if you're using the high school method, put it underneath both sides, put a big old exclamation or a big old line underneath of it. Bring your equal sign straight down. We have 4 x's on one side, and we have 4 on the other. All right, getting a little sloppy, Mr. Callan. Now, I don't want to know what 4 x's are, so we're going to go ahead, divide those into 4 groups. X equals 1. Are we sure? You can always check. Go back to the original equation, 4 times some mystery number plus 11. But now put in that mystery number. We think it's 1, maybe. 1 plus 11 is 12. 4 sets of 12 is 48. And naturally, it is equal to the same amount. It's a true statement. All right, y'all. That's what I got for today. Go ahead into the homework. Problems pages 235, 236, number 1, 2, 3, 4, and 5. Don't forget, number 5, do it in your book and on the computer. And take care, do well. Let's grow. See y'all.